iOS has this feature where you can hold down on an image and pull an object out of it. So I sat there at 3 a.m. one day and wondered how they did that. I came up with the idea that they could find the edges in the image, then select each pixel from the user's press to the nearest edge. But that just sparked another idea. How do computers see edges? To solve any problem, we first need to define it. You'd agree with me if I said this line was an edge, right? Let's prove it. We already know the file size, image dimensions, and the color values of each pixel. Well, let's pick 2 points, A and B. The most notable difference between these points is their color values. Using this information, we can define an edge as such. An edge is a boundary or region in an image where there is a significant change in intensity or color values. If you've taken calculus, it might help to think of this as taking the derivative of an image. This works for every image, by the way, not just a sample. Note that a more accurate representation will be the following, but we'll get into that later. Now, this wasn't exactly straightforward to implement, so let's break it a little bit further. We know we want to find the change in the intensity of the pixels, but how do we do this using code? Let's extract this region as a test subject. The pixels surrounding it are as shown. If we want an edge in relation to the center pixel, we need to look at its sides. If we assign values to each of these positions, we can ignore the center pixels by setting them to 0. Since we want the difference between the top and the bottom pixels, we'll assign them opposite signs as shown. Add a little blur, and we've solved the first matrix in the puzzle. Since we've found the matrix for the edges along the x-axis, we can just turn it 90 degrees to find the y-axis edges. Now we can apply these matrices to the chosen image by convolution, and receive their respective edges. Now if only there was an equation that could find the resultant between x and y. Plug in the x and y edges to the Pythagorean theorem, and we have our almost result. Now all we have to do left is finally normalize the range, and what we have is known as a Sobel operator. Since this algorithm gives us the x and y edges separately, we can use some vector trigonometry to calculate the angles of each edge, resulting in something that looks like a normal map. Alright, you've understood everything? Let's code it. Now you could just use a library like OpenCV and call it a day. That's no fun, so let's hop in VS Code and make it from scratch. We're going to be using OpenCV for reading and displaying the images, and NumPy for the calculations. First, let's read the image into 2 two-dimensional arrays, one in grayscale and one in color. We'll hardcode the matrices we created before, then convolve them with the grayscale image. Here's the code to perform a convolution, by the way, but I won't explain that in detail this video. If you want a conceptual understanding of convolutions, tell me in the comments. We'll now apply the Pythagorean theorem to the edges, normalize the result, and solve for the angles of each edge. Oh, and it's better if you blur the image a little beforehand. Now display everything, and you've made your first Sobel operator.